Hello and welcome to Talk Julia. My name is David Amos.
And my name is Randy Davila.
So Randy, this week I posted on Twitter a question for all of our listeners. That is, what's your favorite Julia package? And we got a whole bunch of responses and a whole bunch of packages. A lot of them I was aware of, but there were several that I was not aware of and have since checked out, and they are really, really cool. So I want to talk about some of those on this week's episode. But first, I want to just scroll through and kind of show you what some of the people were saying. So things like this Revise package, the Jump package, which we talked about in last week's episode. Lots of people mentioned things like DataFrames, and Pluto was mentioned several times. Both of us like Pluto, but there was kind of a common theme I saw as I was scrolling through all the answers. I think the two most commonly mentioned packages were Revise.jl and DataFrames.jl.
Yeah, I'm noticing that.
Yeah, they're kind of all over the place. And there's, a lot of other ones. Some people are like, I can't just narrow it down to one. I have to list like 8 of them. So things like distributions, chain rules, tables, lazy arrays, flux there for the machine learning. Here's another one for Revise. It was nice to see what everyone enjoys using in Julia, so that we can kind of dig into some of the stuff we're not familiar with and see what cool stuff we haven't learned of yet.
Yeah.
So Randy, I know you were already somewhat familiar with this package, but you want to take off with
the DataFrames? Yeah. So DataFrames.jl is an excellent Julia package for dealing with tabular data, and it builds on the notion of data frames from the Python language and from the R programming language. As I was looking through the documentation and looking at the examples, unlike some of the packages that we've encountered in the past, all of the examples work as they should. Like,
that's good.
If you type in exactly what they have on their documentation for their examples and you run it, it will run. So for those beginners out there that are transitioning into Julia and are familiar with something like Python and R, and you do analysis of data, or you do machine learning, DataFrames.jl is an excellent package to start with, to kind of get used to the ethos of programming in Julia, right? Like using functions instead of methods, right?
Yeah.
Indexing through rows as like a matrix instead of looking at like a method that calls a row on a given data frame. And do not shy away from them. When I first started programming with Julia in my machine learning course, I saw data frames, but that was before I even knew about Python data frames really. I just never used them, right? So I kind of avoided them. And now that I use them in both in Python and Julia, I could never go back. So I made a little Jupyter notebook that I'm going to kind of talk everyone through. And then also I'll put on my GitHub repository that I recently made for Talk Julia. In this notebook, I'm going to kind of describe the basic functionalities of data frames. So first off, I'm going to use the following 3 packages: R datasets to grab the iris dataset, plots to plot things, and DataFrames.jl, of course, right? What I'm going to do is I'm going to just type using R datasets, plots, and data frames. And then to access the iris dataset, which is this famous dataset from machine learning, I'm going to go into the R datasets package and grab the dataset function. And then inside of that function, as the first argument, pass datasets, and the second argument, pass iris, both as strings. This will return a data frame, but we still need to import the data frames package to manipulate this data frame once we've read it in. So if we want to view the first 10 rows of this data frame called iris, we have to call the data frame's first function. Right, so this isn't like this is akin to the head method with Python, and it will appear on your screen underneath your cell, and it looks very nice. I love the way the data frames appear in notebooks. If you're not familiar with the iris dataset, this dataset consists of 4 measurements on 3 different species of iris flowers. So there's sepal length measurement, which would be column 1, sepal width, column 2, petal length, that's column 3, petal width, column 4, and then species column, okay? And it's just tabular data. So it's kind of just, it's a small data set, 150 rows, 4 columns, but it's really useful to learn with, and I encourage you to go and play with it. While working with Julia data frames, there's several different ways to access a given column of data. There's more ways to do this than there are in Python. I'm counting on my screen 1, 2, 3, 4, 5 different ways to access a single column. So for example, if I wanted to access the sepal length column of my iris data frame, I can use this dot notation and do iris dot sepal length as the column name appears. So iris dot sepal length. Now this is very similar to Python. Python data frames also use this dot notation to access columns, but that's just one way. Another way would be to use what I would call the colon string way. You sort of treat iris like a matrix. So you type in iris and then you have your closed brackets. And then the first entry, you put the colon, which is representing every single row.
Right.
And then comma, and then you can put in the string sepal length. And then that will also return that given column. Now, for whatever reason, I've noticed that the notebooks and code that I've seen don't typically use the colon operator to indicate all the rows. They use the bang operator. So in place of the colon, you can put an exclamation mark, and that will also give you every single row and the sepal length column. So again, iris brackets, and inside the brackets, the first entry will be a colon. And then the second entry, so colon, comma, the symbol sepal length, and then close your brackets off. So Julia symbols are indicated by colon, and then right there attached to it, the name of the symbol. So colon, comma, symbol sepal length will also give you that given column. And then finally, as always, you can replace the colon by the bang operator, and it will also give you that column in question. So quite a few ways to do this. I think the preferred way for a single column, it seems to be either the dot notation, so like iris dot sepal length, or iris bracket bang comma symbol sepal length close bracket. Maybe we want to select the sepal length and sepal width columns of our data frame object. Well, this is very similar to Python, but also kind of mixed with what I just previously was talking about with a single column, where you treat, so you have your data frame called iris in this case, close bracket, and then any number of ways you want to choose all of the rows, comma, and then you pass it an array as your second value, and that array contains the column names that you want to grab. And you can do this in several different ways in Julia. You can pass in string names of the columns, or you can pass in the symbols of the columns. And again, symbols are colon name, like colon connected to the name. And again, I think the preferred way of accessing, for example, sepal length and sepal width columns, from what I've seen, would be iris, bracket, bang, and then pass in the array with the entries symbol, sepal length, comma, symbol, sepal width. Close array, and notice that it returns, on my screen, it returns a data frame object. You can tell by the output in front of me. I forgot to mention that when you access a single column, it returns an array, right?
Yeah, you get that vector type, which is kind of nice. It's like a different from, say, something like pandas, where you've got these two different types, right? Like a data frame and a series type.
Right,
Here you
right.
have a data frame, but then for just like a column, it's just a vector.
It's a vector, and that points towards, I think, the general feeling I have when working with pandas data frames is that they're not matrix-like. They're like more like tabular, but they don't feel like matrices. And Julia data frames, they feel like matrices when you start working with them. For example, that brings me to my next point, accessing the rows, you indeed treat the data frame like a matrix. So like if you had a matrix and you wanted to access every single column, but just the first 50 rows, you would use slicing, right? You would say matrix bracket 1 colon 50 comma colon. That's like slicing through the first 50 rows, all columns. And that's exactly how you would get the first 50 rows of a data frame. Another cool aspect of Julia data frames, just like with Python data frames, is that we can compute like basic statistics by calling the data frame DataFrames.jl describe function. You call that function, you pass in your data frame, and it returns another data frame, but this data frame now contains variable names, the mean of each column, min, median, max if there's any missing and things like this. So it's kind of useful to do when you first are encountering a new set of data. You want to know these basic statistics. A lot of times I'm dealing with problems where I only want to grab certain values from a data frame subject to some condition. Like suppose if I want to access only the rows of my data frame where the column entry is Setosa, or the species entry is Setosa, right? From what I can tell, there's not a natural way to do this just using DataFrames.jl. There are ways, but they seem kind of convoluted. And the best way that I've found was to use something called DataFrames Meta. So DataFramesMeta.jl, it's kind of like built on top of DataFrames.jl to help with these types of tasks.
Yeah.
So if I would like to access all rows of my data frame that have Setosa in the species column, I import DataFrames Meta, and then that gives me access to this @subset macro. The first argument that I give this macro is my data frame iris, and then I do comma, and then I give the symbol species, which that's the column that I want to focus on, and then dot double equals Setosa in strings. So I'm like checking to see what entries are Setosa string values, and I use the dot double equals because I'm passing that double equals across the entire array of possible values.
Yeah, the broadcasting.
Yeah.
I like that.
Yeah, it's very clean looking.
Yeah.
So next up, I want to mention something that is very frustrating for me in Python. So a lot of times I have measurements of data with corresponding categorical labels. And I just want to use matplotlib or seaborn or something like that to plot those data points in 2 dimensions, color them, and have those colors assigned with a label that will appear in the legend that's easy to do in like one function.
Yeah.
As far as I can tell in Python, if you want to do that, you have to do one at a time scattering. I know some of you might like say, oh, you can use the built-in plotting functionality on data frames in Python, and you can do like dataframe.scatter, blah, blah, blah. It's still not that easy to get exactly what I was saying. Julia data frames together with the plots.jl package makes this awesome. So in front of me, I set my theme equal to dark just because I like dark themes. And then I'm going to use the plots scatter function. So I'm scattering as my X value, iris dot petal length, so that column. And then for my Y values, I'm scattering iris dot sepal length, so that appears right after it. Then I set my X labels, but then I give the keyword argument group, and I say group equals to iris dot species. This will assign to each color that I'm about to define the appropriate species. So Setosa should be colored red, versicolor should be colored magenta, and Virginica should be colored light sea green. That's what's going to happen. And it does it in such a natural way. And it makes the legend labels correct. And then if I look at the plot generated, it did what I wanted. But yeah, so I think that I'll go ahead and pass it on to David. I've talked enough about data frames and plotting them and stuff like that. So what do you got, David?
The package that stood out the most to me was something called Revise.jl, and I'd never heard of it. And Randy, I don't know if you've looked at it or not, but
I haven't.
Just given the name Revise, like what do you even think of?
I don't know. Like I can't even make a guess at what that would do, honestly.
So you like to work interactively, right? In like a Jupyter notebook or like in a IPython REPL?
Yeah, of course.
Yeah. So one of the things that comes up a lot is like, let's say you're building a little project and you're doing things interactively in your REPL, but then you've also got like a file you're working on where like maybe you're experimenting with something in the REPL and then you get it right and then you go put it in your file and then you like, I don't know. This is something I commonly do. I don't know if it's something you commonly do, but this kind of
I'm trying to think if I've ever done that. And I don't know.
Really? Okay.
Yeah.
Well, I like to like start out in a REPL, right? And just experiment with code and see like whatever problem I'm trying to solve, like can I kind of hack together a solution? And then I can kind of move it into a file and start cleaning things up and everything. But one of the things you run into is like, okay, you've made a change in your file, but you want to go back and have those changes reflected back in your interactive session. What would you have to do? You would have to restart like Julia or Python, and then like whatever changes, it would reload that file when you import it again or include it or whatever. So what Revise does is allows you to do everything I just said without ever having to
reload or restart.
Yeah, without having to restart your REPL. So it's kind of like, I don't know if you've seen this in IPython, there's this, I think it's percent reload.
No, I have not.
So there is this like reload thing, which you can use to kind of hook into a file or a package and have some reload going on. But it's a little, I mean, it's nice, but it's a little clunky. So Revise makes this experience absolutely amazing. I have to show it to you so you can see how this works because it's super, super cool. I see why so many people really liked this package, and I can guarantee you this is going to become a staple of of how I work with Julia. Okay, so I'm in VS Code and I have a project open where I've got a file called myscript.jl, and it's just got a single function inside of it called greet that returns the string hello world. So what I'm going to do is start a Julia REPL, and I am going to include myscript.jl. Okay, I've got this greet function, right? And I can call it, and I see printed hello world.
So if you call that function and it works, but now if you change myscript.jl somehow, you have to completely reload the Julia REPL.
Right. So if I say this to say hello Randy instead, right? And I saved it. I come down here and I call greet again. It says hello world. It doesn't say hello Randy. So normally I would have to exit my REPL, right? And then I would restart it. And now I could include my script and call greet. And now it says hello Randy. But here's what's absolutely amazing. So I've already got Revise installed here. So I'm going to just say using Revise. Now, rather than using the include function to include my script, I can use include T, which stands for track. This comes from the Revise package, and give it myscript.jl. I misspelled include. There we go. Include T. So it's now included, and it should still work here. Now, if I go up and change Randy to hello Revise, I've saved it. I come down here and call greet again, and now it says
that's
hello
awesome.
Revise.
Now that I understand what you were talking about, yes, I've done this many times on like bigger projects, and that's pretty awesome.
So it'll track changes you've made inside of your scripts. If you're working on a Julia package, you can have it track all the changes while you're developing your package. So then you can just jump right back into the same REPL session and try out the changes you just made.
I know how much you love this. This is like, especially like the type of coding you do, like you're always restarting your session.
Yeah, I do a lot of restarting. It solves a pretty big pain point of mixing the benefits of interactive programming with the benefits of, having like a script that you're maintaining. So you kind of get both at the same time. And the documentation for Revise is fantastic as well. But there's this cool section called Secrets of Revise Wizards. So if you're working on a really large project, you're probably writing tests. Hopefully you are. Anyway, one of the problems that comes up with this test-driven development is you have a test that's failing for some reason. You have a bug somewhere, and you go and you try to fix the bug. To really do test-driven development, if you really want to follow the rules really strictly, one of the things you would do is you're supposed to write a test that should pass first for whatever changes you're about to make. Well, sometimes you have to basically fix the bug in order to know like what those changes are. So it can be difficult. So using Revise, it gives you this kind of workflow where you can fix the bug while simultaneously developing a high quality test. Then you can verify that your test passes with the code you just fixed. Then you can use git stash to like stash the changes you just made and kind of take it away, but save it in memory so that it's as if you didn't make the changes. And you can now check that your new test fails on the old code, which it should. And then once you verified that, you can pop the changes you made out of your git stash, make sure the test passes again, and then commit it. So it gives you this like really nice workflow. And you can do all of that without ever having to restart your Julia session. So there's all sorts of cool stuff in here. Like I said, the docs are really, really good, cover a lot of use cases, lots of examples. There's a whole cookbook of like different ways to use Revise and sort of suggestions on how you might do things and examples to walk through. So really, really good stuff. And yeah, thanks everyone for mentioning this because I'm really, really happy that I found this awesome package.
Definitely tell.
Well, that covers, I think, some of the packages we wanted to talk about. But what have you been up to this week, Randy, doing in Julia?
I'm currently, so I always mention this, but I'm teaching machine learning this semester. And so tomorrow we're wrapping up our like a 3-part lecture series on this single neuron model. So this is a computational unit that's supposed to mimic biological neurons with like axons and dendrites and things like this. But I kind of wanted to talk about it because I've been doing this in Python, and yesterday I translated it to maybe some ugly looking Julia code, but it's still simple. More or less, you can think of it as this model takes in an input signal, weights it, and then that like weighted sum of the input signal is stored in half of the neuron pool, and that's called the pre-activation value. The second part of the neuron is called the post-activation value, and this is a value that is determined by what's called an activation function. So signal goes in, it gets weighted pre-activation, and then that gets passed into a function, and whatever that function is does something to that value, and then it spits out a predicted label. And these labels can be like numerical labels or classification like labels. It's a model for computing a function, basically, that we hope will approximate our given data's labels. And the way that we measure that is with something called a cost function. So that's the general model. And it turns out that this single neuron model can be used in 3 different types of learning algorithms, machine learning algorithms: the perceptron, linear regression, and logistic regression. It just depends on what we choose as our activation function, which is what spits out our y hat, right? So these 3 machine learning tasks are really just specific instances of this more general model, which means that if we're trying to program this, we can maybe program a single model that trains all of them, and we can make it like custom to use on whichever one we want.
Yeah.
So I wanted to see what this would look like in Julia, and I haven't done this in Julia in years. So I had several ideas, but the one I settled on was to make a mutable struct called a single neuron with two entries in it, 2 fields, I mean. W underscore, which is weights and biases together. So the last entry of this array will be the bias, all of the other ones will be the weights. And then the errors field is just an array that's going to accumulate all the errors as it's training. So I want to look at those errors over time to make sure it's actually learning something.
Real quick, I guess we should be clear too. When you're talking about error, you're not talking about like code errors or like a.
Yeah. I'm talking about like loss, like how bad the model is performing.
Right.
Like what the cost function is. But yeah. So then I define the sine function, sigmoid function, and linear regression function, all really easy to do. I should probably point out with the sine function, I love using this ternary operator. So sine of z returns z greater than or equal to 0, question mark, 1, colon, -1. So if the first Boolean value there is true, it returns a 1. Otherwise, it returns a -1.
Yeah. I have mixed feelings about these ternary operators. It's super concise, which can be really nice. But I sometimes struggle. I don't know why. It seems like it should be simple to remember. The first one is what happens if it's true, and the second one is what happens if it's false. But sometimes I struggle to remember. I don't know why. And I'm like, wait, is it the first one is false? Yeah, I don't know. Can't remember.
I'm just used to that kind of thing because of this NumPy where function. It does like basically the same thing.
Right.
The first one. So after I define those functions in my mutable struct single neuron, I define a mean squared loss function for a single entry, and then a cross entry loss, which I can't like go into the details of why that is, but I do have I am recording all of my machine learning lectures this semester, and I do go into detail into why that function is used for a loss function, which will probably appear tomorrow evening at some point. Okay, so I have my activation functions, I have cost functions, I have a neuron that I can work with, a mutable struct, and then I define a function called train. And this function train is going to take in a matrix of vectors x and then a y vector, which are all the labels. And then I give it an activation function and a loss function. Now, depending on which of those I use, this could be a linear regression, logistic regression, or perceptron. This train function just depends on what I choose to put in there, right? For example, earlier I was talking about looking at the iris data set. I can grab the versicolor and virginica flowers from that data frame, and I'm going to look at petal length and sepal length as my columns. And I convert that to an array by just calling array on that data frame, and it converts it to a matrix. And then I make my target labels for each of those flowers. So like versicolor, I give labels 1, virginica, I give labels -1. And then I train it, and I train it with the sine function and the mean squared error. So this is the perceptron algorithm. If I choose my activation function to be the sine, it's perceptron. And if I run it, you can see that the cost function is decreasing over all the epochs, which is kind of nice. If I do a similar thing, like the same data, but pedal like the same data, but then I pass in the sigmoid function and the cross entropy loss, and I change my targets to either 0 or 1, then I get logistic regression. So it's kind of like a general framework for these 3 different models. It's not the prettiest thing, but it still didn't take me long. It took me like an hour to figure out after being rusty.
And how many packages did you have to import in order to implement those things?
Oh, none.
None. I know.
Yeah,
Super
absolutely
cool.
none. Yeah, so this is all from scratch, and it solves those 3 problems all at once, and it's pretty fast too. I could make it faster, but it's already it's good.
I think one of the things I'm really falling in love with about Julia is that it's got all the sort of, numerical and sort of scientific kind of stuff just built into the core, but without sacrificing like the, general purpose kind of aspects of the language as well. I really enjoy that. But, speaking of this mathy kind of stuff, I've been fooling around with making some animations in Julia over the last week. And I wanted to share some of the tools and some of the things I've been learning about that. And they've been kind of, math related animations that I've been doing. And I'm using a package that, so I should, I guess, start by saying one of the packages that people mentioned a couple of times in the tweet that we mentioned at the beginning of the show was a package called Luxor, which is for making graphics, that kind of stuff. But it's primarily focused on like static images. So not a whole lot with animations and things like that. I think it can do a little bit of animation, but it wasn't really designed as like an animation library. So there's a package called Javis, which uses Luxor, but is really a animation engine. And it's inspired by the Manum animation engine from Grant Sanderson, 3 Blue, 1 Brown.
Oh yeah.
And also there's other animation engines like processing is a big one that's in Java. And I know a lot of people that do kind of like creative coding and stuff in Python and are using some Python wrappers for processing. Well, Javis is Julia's animation engine, and it is awesome because of how concise it is without sacrificing readability, in my opinion. It's been really easy to kind of jump in and sort of understand kind of the general framework for how things are working. But I mean, just to kind of give you an idea. So this is some code I wrote. So what this is going to do is it's going to draw 12 dots on the screen. Each dot is going to have a radius of 20 pixels. And I've got this color palette that I've selected, which is just kind of like a rainbow color palette. And the speed, kind of, you can control the speed of how these things are moving. I'm going to set that to 10. This is basically degrees per frame. So there's going to be some circle related math going on here. And I've got a function that can draw a circle. So it's just a standard Julia function. So I compute sort of like the angle. So I'm going to put all these 12 dots equally spaced around a circle. And then this is a parameterization of the circle's position in terms of the frame index. So I'm using the frames, like each frame, the position is going to get updated. So I won't go into all the, the math that's going on here, but that's what I'm doing there.
And I kind of want to point out that right here you have, it looks like your radius is equal to 230 times cosine of some angle stuff. There's no multiplication symbol in between 230 and cosine.
Yes, I really like that. And it's very clear, at least, the highlighting that takes place here in VS Code with this theme I have, you can clearly see that those are separate things, right? 230
Right.
is a number value. It's green. And the cosine function there is a function. It's got kind of this beige or, kind of.
And for those of you
color.
that don't know, you have to put a multiplication sign with Python or R or something like that.
Right. Yeah. But Julia, you can, for certain things, yeah, like you can use it as like a coefficient, like it would look like when you write it out mathematically. So anyway, so I, computed the position of the circle for, a given frame in the animation. I can set its color. There's this set hue function that you can pass a color to, and it'll change the color. And then there's this circle function that you can use to actually draw. The center of the function will be at whatever the position I calculated. It'll have this radius. And then, talking about symbols earlier, there's these symbols to determine like, is it a filled circle? So like a disc, or there's another one, which is a stroke, which is like just a circle that's not filled in. So it's just the edge of the circle. And I think there's some other ones, but these will be filled. And then you create this video. There's this video type, and you give it, your width and height and however many frames you want to be included. You can set the background color, which here I've set the background to be black. And then at the end, I just loop over the range 1 to the number of This big N is the number of circles I wanted to draw. So I think it was 12. And then, drawing the circle there. And then finally, there's this render function, and you pass it, your video and a path name where you can store it. And it can do GIF files or GIF if people insist. It can also do MP4 files. If I run this, it shouldn't take too long to compute here.
That code was very simple.
Yeah, it's just a few lines of code, right?
Yeah.
So you saw it's just, I think it's less than 20 lines. And that's what we got.
That's
just
awesome.
a few lines of code. So I know people listening to this can't see this, but I'll put a link to this. But to describe it, it's like a circle of circles that looks like it's rotating around this square frame in the GIF. Here's what's really interesting about this, though. So if you actually look at just pick one dot and follow it with your eye and focus on it, what you'll realize is that each of these circles is traveling along a straight line path. There is actually no rotation occurring at all. And yet, when you look at it, you would swear that there's something being rotated.
Yeah, definitely go to our YouTube page and watch this for those of you listening. It's pretty cool looking.
So I did that animation and played with some other ones as well. This is what the pulsating circle looks like.
Yeah, that's awesome. I want to learn how to do this.
I know, right?
I'm gonna look at your code later.
By no means have I mastered any of this stuff. I'm just starting to kind of scratch the surface and figure out, how this all works. But I do have a little bit of experience using Manum. Not a lot, but very limited experience. And Manum is really cool and really powerful. And you can do some really, really incredible stuff with it. But the learning curve was a lot steeper than getting into Javis here. So I'm really excited to dig deeper into that and maybe even use it to make some animations and stuff for some YouTube videos that I have planned and things like that I'm working on. So
take that single neuron I did and make an animation of the line learning to fit the curve in the regression example.
Yeah.
It's awesome that our listeners are suggesting packages so that we can learn about these things really fast. Because I would imagine it would take me a long time to find something like this.
Yeah. I mean, maybe I would have had the idea in knowing that I've used Manum before, but I wonder if there's something like that for Julia. But still, yeah, it's the influx of just all the suggestions and stuff we've gotten asking people has been really helpful. I'm still super excited about Revise. That's just going into my global Julia environment, and I'm just going to use it everywhere now. So, all right. Well, Randy, thanks so much for hanging out again. Love talking Julia with you every week.
Same here.
We'll see you and everyone else next week.
All right. See y'all later.
All right. Bye.